Right. In this video, we're going to begin looking at Chapter 6 and the normal distribution curve and how to use the z-table. But before we do that, we're going to have a quick review of the normal distribution that we started to look a little bit at in Chapter 3. If you recall, this is what the normal distribution looked like with the mean here at the center or at the maximum value here. This is where the mean was. And these are our x values depending upon what our problem is about, and this is z. This never changes. This is our standardized z-score for whatever x value may be, and the z-score for the mean is always 0. And then if you remember, one standard deviation above the mean was about here, and one standard deviation below the mean is about here. And we learned that 68% of your population, whatever it is you're looking at, will lie between one standard deviation above and below the mean. And that's what I'm talking about. That is that percentage, that is that population, that is that probability. So the area under the curve will always be that. And that's going to be a very important concept as we move forward. So let's do a quick example for let's give this some meaning. Let's say we are talking about IQ scores. Okay, so X in this case is going to be IQ scores. And let's say we're told that the mean IQ score is 100 for a population with a standard deviation of 15. Right, so that means it's here. So if I were to ask you what is the IQ score of somebody one standard deviation above the mean? Well, we know one standard deviation is equal to 15 points. So 100 plus 15 brings us to 115. So it's 115. One standard deviation below the mean would be also 15 points below. So 100 minus 15 is going to bring us to 85. So we know that 68% of the population has an IQ between 85 and 115. Okay, and that's how we use the normal distribution curve. And if you recall, if we moved it on out to 2 standard deviations, we ended up with 2 standard deviations above or 2 standard deviations below. Then we moved on up into 95% of our population. All right, and I'm sure that you can figure out those z-scores. And let's say I asked you, what is the IQ score of somebody with 1.5 above the standard? 1.5. All right. Well, what is that x value? Okay, and we can move back and forth between x and z. We've got two formulas. We are told to find the z-score given x. You take the x and subtract the mean, divided by the standard deviation. So doing a little bit of algebra on this, if you multiply both sides by the standard deviation and add the mean, you will get x equals z times the standard deviation plus the mean. So those two formulas are very important. And in this particular problem, we could say if we know the z-score is 1.5, then x would equal 1.5 times the standard deviation of 15 plus 100. And then you can just do that on your calculator, and you will get a value of 122.5. All right, so someone with a z-score, or someone with an IQ 1.5 standard deviations above the mean has an IQ of 122.5. And that's how you move sort of back and forth. All right, so what happens if I want to find the percentage? What percentage of the population is below 122? Okay, what percentage of the population has an IQ of below 122.5? I wasn't given a nice value here, and so that's what takes us into Chapter 6, and we're going to move on now into the next slide. All right, so cleaning things up a little bit, I am asking what percent of the population has an IQ less than 122? So if here's 122, and if you recall, this is, we'll just quickly go through again. To find the z-score for an IQ score of 122, we would use x, which is 122, minus the mean, which is 100, divided by the standard deviation. That gives us a z-score of 1466. So because I rounded it to 122, I'm going to actually change this 1.46666 going on forever, so I'm going to actually round this up to a 7. I'm going to carry it out to the hundreds place, and you'll see why in just a minute. So this is a z-score of 1.47, corresponds with an IQ score of 122. And what population has an IQ less than 122? Less than. So that's going to be all these people to the left of 122. And this is our population. And that was just a very important thing to remember, that that area under the curve is your percentage or probability. And I'll write that down in a minute. Actually going to write that in this color right here, because I think that's a very important thing to remember. And I'm going to write it right here. Area under the curve is probability or percentage. It depends how you ask the question. But both, probabilities and percentages are both decimals. And you know that 100%, or a probability of 1, that somebody lies under this curve, it's 100% of your population is under the whole curve, going on forever this way and this way. Okay, so this is very important, and we'll be talking about that over and over and over again, understanding. So that's this area under here. And how do we find this area? Well, we use what's called a z-table. And this I passed out in class, and so let's just take a minute now to look at this. This is what we call the positive z-score, and you'll notice if you flip it over, there's a left side that says negative. And all that means is this table here is going to give us the area under the curve to the left of this z-score. It's going to give us this area here. So along this table here, you have your z-score to the tenths place, and this direction is out to the hundredths place. So we had a z-score of 1.47. So if we'll just scroll down here, 1.47, 1.4 is right here, 1.4 is right here, and 1.07 is right here. So we're going to just, where do these two meet? They meet right here. Okay, 1.47 is 0.9292. All right, so let's go back and put this on. And we can see now that this is equal to, I'm going to go back to my right color, 0.9292, 0.9292. And that is, like I said, that is a percentage or a probability. In other words, what is the probability if you randomly selected someone that their IQ would be below 122? That probability would be 0.9292. Or the other way of putting it is like I did here, what percent of the population has an IQ less than 122? It is 0.9292, or roughly 93% of the population. So this is what we would call the 93rd percentile, the 93rd percentile. And that is how you use the z-table. Let's take a look at it, another example on the next slide. Let's say in this problem I ask, what is the probability that if I randomly select someone, they will have an IQ of greater than 93? Okay, what is the probability that if I randomly select someone that their IQ is greater than or equal to 93? Okay, so the first thing I'm going to do is shade the area that I want, and now we're talking about greater than, okay? So I'm talking about all these people here. What's this? What is this space here? What is this probability here? What is this percentage? Okay. Well, unfortunately, our z-table does not give us areas to the right. It only gives us areas to the left. So I'm going to have to find out the z-score for this value and then look up this area to the left, okay? I'm just going to shade that now because what I want is the area to the right. All right, so help me out. First thing I need to do, because I don't have a table for IQ scores, I only have a table for z-scores, I'm going to have to standardize this z-score. I mean this IQ score of 93. So what is its corresponding z-score? Well, I know that z equals 93 minus 100 over the standard deviation of 15, which equals, you do that on your calculator, negative 0.4666 going on, so negative 0.4, we're going to round it to the hundredths place, always the hundredths place, because that's how far z-table goes. So this is negative 0.47. All right, so now and that makes sense that it's negative because we are to the left of the mean. So these are all our standard deviations below the mean. Below the mean is negative, above the mean is positive. Okay, I can't look up the z-score, this area above this z-score, but I can look it up below. So let's go ahead and do that. Now what I need to do here is I'm going to close this and open up my z-table that is to the negative. So let's close this. And where was that negative z-score? Here it is. Okay, so and you notice here now it says negative, and that just means that it's because the area we're now looking at is below the mean. It's below the mean, below this z-score, because it's always going to use to the left. All right, so our z-score was negative 0.47. So let's go over here, negative 0.4, negative 0.4. Negative 0.4. So we're way down here. Negative 0.4. Here's the negative 0.4. And we'll follow it over 5, 6, 7, right here. 0.3192. 0.3192. So let's go back to our work. 0.3192. Yay. All right. Oh my. Here we go. 0.3192. Okay. 0.3192. So the probability that x is going to be greater than that is going to be this this whole area subtracting off this bit. So this area over here, because we know the whole area under the curve is 1, we're going to subtract the 0.3192, and that will give us 0.6808. So the probability x is greater than 93 is the same thing as the probability z is greater than or equal to negative 0.47, which is equal to, one way of thinking of it is 1 minus the probability z would be less than negative 0.47. It's always good to put it into the less than, which is equal to 1 minus the 0.3192, which is ultimately equal to 0.6808, which is roughly 68% is our final answer. This is about 68% of the population will have an IQ of greater than 93. So that's how you use the z-table to help you with greater than. All right, in this next slide, we're going to look at betweenness. So let's say we want to find the probability that somebody has an IQ, or what percentage of the population has an IQ between 93. And out here, 122. Okay, and I'm picking these numbers because we've already done a lot of the work for them. So we know the z-score here was negative 0.47, and we know the z-score for this one was 1.47. All right. But when you have something between this like this, so now we want to find the probability that x is actually greater than or equal to 93, but less than or equal to 122. So what percentage of the population lies between these two values? All right. So we are going to have to do some subtraction again because, again, our table, our z-table, only helps us to the left. All right. But let's think about this. Another way of writing this would be to write it as the probability that z is less than or equal to 1.47, but greater than or equal to negative 0.47. And then that could also equal the probability of z is less than or equal to 1.47, okay, minus the probability that z would be less than or equal to negative 0.47. And let's take a look at why that is. Well, we looked it up before. We know the probability of z being less than 1.47 is 0.9292. We did that in a previous slide. 0.9292 minus the probability z was less than 0.47 was actually 0.3192. And I'm going to now take a break before we compute that and show you why it is this difference is this area. All right, so if you look at the area of 0.9292, and I'm going to use a different color here. Let's switch to this sort of teal color. Okay, so this value here, you can see, would be everything less than 122 or less than 1.47. Okay, that's all this here on out into eternity, negative. Okay, it's going to go on forever that way. That's the 9.9292, the basically 93%. Okay, and you can see that if I were to subtract off this area here, I would be left with this pink part in the middle. So let's switch here. I'm going to go back to a little yellow. So this area here, you can see is the 0.3192, which we looked up in a previous slide. It's the area less than 0.47. Okay, so when you have betweenness, that's a good way, that's the way you want to tackle that problem. And so then you can just do that on your calculator because you always have to work to the left. And that is going to equal 0.61, or again, about 61%. 61 is in this original pink space. 61% of people will have IQs between 93 and 122. And that is how you do betweenness. Okay, now we're just going to do one last slide to look at one more way that we deal with the z-table, and that is when we have something in the reverse. Let's say I ask what IQ score is the 95th percentile. That means, or I'll actually write the word percentile, 95th percentile. Okay, and what that means is what score is such that 95% of the population is below that score and the other 5% is above it. So if you've ever taken a test before and you scored in the 95th percentile, you know it's good. But Why is it good? It's because 95% of the people did worse than you and 5% did better. You're very, very high. So now our question is, what is this value here? What is this X, that this magical number that is the 95th percentile? All right, so when you have 95th percentile, they're giving you the percent. They're giving you the percent. That means they're actually giving you this whole area. We're working in the reverse. We're not asked to find it. We are actually told that this is 95% of the population. All right, so we're going to have to use the z-table in the reverse. First thing we want to do is write 95% as a decimal. And because the z-table carries it out to the hundredths place, or to the 10,000th place, I'm going to write it as 0.9500, 4 decimal places. All right, so that's just one and the same. Okay, and then I'm going to pause, go over to our z-table. Because I'm on the right side, I need to use my positive z-table because I am to the right of the mean. So here's our z-table. And now, because I know the area but not the z-score, I've got to work in the reverse. And this is a little trickier, but so we're just looking for 0.9500. And I can see right here, 0.9495 and 0.9505. In fact, there's a little dot right here, which is exactly where 0.9500 would be. So I can see that this is 1.6, and it's between 4 and 5. So I'm going to write it as 1.645. That is the z-score that goes with the 95%. So putting this back now on our, coming back to our table or to our graph, I know that z must equal 1.645. It is an IQ score that is 1.645 standard deviations above the mean. That's the line where 95% will be below. That is the 95th percentile. So now I know the z-score, so my last step is to find this x. All right, and I'm going to go back up here, use a different color here. I'm going to go way up here and use the formula we have. So we know that x, when I know x, I've given z, but I have to find x. I'm going to use this formula, x equals z times the standard deviation plus the mean. So it equals 1.645 times a standard deviation of 15 plus a mean of 100. That is going to equal, and you can just go ahead and do that on your calculator, 124.675. All right, but I'm going to round that to about 125. So x equals 125. That is your 95th percentile score of, if you have an IQ of 125, you are in the 95th percentile. 95% of the people are below you. So that is how you use your z-table. Go ahead and practice with the homework. Good luck. Homework number 14. Homework number 14 you should now be able to tackle.